Good morning, ladies and gentlemen. Today we're going to go ahead and figure out how to find the upper and lower bounds of a set of data on a scatter plot. So what we're going to be working with today is what it does. It gives you a range of possible predictions for these upper and lower bounds. So instead of saying using your least squares regression line, the answer is 12. You're going to be able to have a better prediction saying your answer is going to be between 10 and 14. And that least squares regression line is going to be right in the middle. So we're going to go through those steps in order to find the upper and lower bounds instead of just a single prediction line, which is the line of best fit. So we're going to go ahead and look at some data that I took from my students last year, which is their favorite items from Taco Bell, how many calories it has, and what is the cost. So my favorite items, one of them at Taco Bell is the quesarito, and I know it has 650 calories. So I want to go ahead and figure out how much it will cost. Now we'll look and see what that would look like using the line of best fit. But instead of just having one particular answer, we want a range. It'll cost between this amount and this amount. I'm going to walk you through exactly how to do this fairly quickly, and then I'm going to actually show you on Desmos how to get the information. So the very first thing that you're going to do is you're going to make a table of values where your X in this case is going to be the number of calories in a Taco Bell item, and the cost is going to be your Y value. We're going to plug these into Desmos, and from there, we're then going to type in the line of best fit equation, which is right here, y1 tilde mx1 plus b. Now that's going to give you the slope of your line of best fit and your y-intercept. So this is what that's going to look like. These are our points, which are our calorie and cost counts for the items at Taco Bell. We typed in y1 tilde mx1 plus b. And then we have our line of best fit where we rounded a bit our slope and our y-intercept, but our equation for the line of best fit is y is equal to 0.005x plus 0.429, which is your y-intercept right here. So that means that if we're looking and seeing about a 650 calorie item, we take a look up here and it should cost a little more than $4 at Taco Bell. Now, these are all of the steps, step by step, that we go through. We input our data in Desmos, we find the LSRL, we type it into the new line. Then we find the data point furthest away, which is this one right down here, 441. And like I said, I'll walk you through this on Desmos. And we're then going to go ahead and we're going to write the same intercept. We're going to write y equals mx, the same slope, and then we're going to change the intercept until it goes through that point, which is the furthest away point from the least squares regression line. Once we have that, we're going to see how far apart these two intercepts are from each other. And then we're going to find the other bound. In this case, we found the lower bound first, so we're going to find the upper bound. So we're going to take this y-intercept, which is 0.429, and we're going to add how far apart these are, which is 1.5, and that's how we're going to go ahead and find our second bound. At that point, when we look here at how much it's going to cost, we know that our 650 calorie quesarito is going to cost between $2.20 and $6.06. And so we're much more likely to be right than just using our initial value. So those are the steps. I'm going to actually walk you through how to do it on our actual Desmos. So here I have my very starting point, which is my table of values. These are the calorie counts. And then right here are my costs. So once again, calories are this way and the cost of the items are this way. Now, first you need to find your least squares regression line, which is simply typing y1 tilde mx1 plus b. Now, this shows you right here what that line of best fit is going to be. And if I wanted to find out 650 calories right here, I know my 650 calories should cost me about $4.15. Now, that's very specific. So we want to find a range of values, and that range, the lower bound and the upper bound, are going to have this least squares regression line right in the middle. So I'm looking to find the point that's farthest away from this line of best fit. And you can kind of eyeball this. As you can see, these two right here that only cost $1 for these two items are the furthest away. And because it's going up, we know this one right here that's the same value is going to be further away. So we're going to go ahead and type in first our line of best fit equation, which is y is equal to. As you can see right here, our m, our slope, is 0.0057. And then you put your x in, and then plus your b, which is 0.429. Now, as you can see, that goes right on top of our least squares regression line. The reason why we do this is I go ahead and take this one, I copy it, I paste it into our next line, but I need a different y-intercept. I want it to go through this point right here. So I'm going to play with my y-intercept. I'm going to follow it down. I want the same slope, but I can see it's about negative, I'm going to say 2. Now, it's not going through that point yet, so I know it's less than that. So I'm going to try negative 1. And now it needs to drop down, so I'm going to try negative 1.1, negative 1.2, negative 1.3, negative 1.4, negative 1.5. And as you can see now, that goes through my lowest point. You've just found your lower bound because it's going through the farthest point away. So this right here, and I can change that plus minus to just a minus, is our lower bound equation. Now we want to go ahead and have one that's the equal distance but above. It does not have to go through one of the points. You're only going through the farthest point. So I need to figure out how far away these two are from each other. So that's a simple subtraction problem. I can see that my first one is at negative 1.5. And I'm going to hover to see what this y-intercept is. And as you can tell, it's 0.429. So I'm going to subtract them, minus 4.29, to find the difference. So I can see that I put my decimal point there in the wrong spot. It's 0.429. I can see that these two here and here are negative 1.929 apart. Now it's distance, so it's absolute value. And I want this y-intercept to be 1.929 above this point of my least squares regression line. So I have that point, 0.429, and I'm going to add to it my difference, which is 1.929. And as you can see, that gives me 2.358. This is going to be the y-intercept of your upper boundary. So I'm just going to go ahead and copy once again my least squares regression line. But instead of the 0.429, I'm going to make it that difference between the two above that mark. So it's 2.358. And as you can see, we now have both our upper and lower boundaries. So what I'm looking for when my value count is 650, I know that my least squares regression line gives me my 413. But with using my range, I can be more accurate and more likely to be correct, which is between $2.21 and $6.06. So that is my prediction, that the cost of my quesarito will be between $2.21 and $6.06. Now, if I go to my Taco Bell menu and I take a look and order that online, I can go ahead and find out how much my quesarito will be. I think that this is probably going to be a specialty. And I take a look, and my quesarito right here is $3.19. So it definitely falls in between that range. It looks like a pretty good deal for those number of calories. Thank you, ladies and gentlemen, and have a great day. The notes are kind of focused on just the steps. Make sure you watch this again in order to get more details. The word of the day is quesarito. Have a great one.